In this video, we are going to talk about arithmetic sequences, and tomorrow we're going to talk about arithmetic series. So in this video, we're going to talk about what it means to be an arithmetic sequence, and that's when there's a common difference between your two successive terms. And it's always the same number, and we call this a common difference. So if I look at sequence A, I go 1, 5, 9, 4, 17. And I can see that every time I'm going up by 4 by adding 4, so that means my common difference is 4. Similarly in B, I can see I'm subtracting 3, subtracting 3, subtracting 3, so my common difference would be -3. And in C, I can see that I'm adding 7, so I can see that my common difference would be 7. So the terms of an arithmetic sequence with a first term of A1 and a common difference of D will be written like this: A1 plus D, A1 plus 2D, A1 plus 3D. And so this would also look like our recursive formula. And so our recursive formula would be, we always list what A1 is, and then our AN is going to equal the previous term, which is AN minus 1 plus D. Now the other formula we're going to use is our explicit formula, which they give us here. And so let's talk a little bit about what these different pieces mean. So our A1 is our first term. Our N is the term number that we're trying to find. Our D is our common difference, as we said above. And our AN is the nth term, or if we're trying to find the fifth term, that would be the fifth term. The other thing to remember is that arithmetic sequences are linear functions, and so our n value is going to increase by a constant number each time, which we also, again, we call our common difference. So let's do some examples. So they're saying the fourth term in our sequence is 15. So that means A4 is 15. And the common difference is 2. They want us to write the explicit and recursive formula for the sequence. So if I'm going to write the recursive formula, I need to know what A1 is, and then I can write the second part because I do know what D is. It's plus 2. If I'm going to write the explicit formula, I would need to know what A1 is, and then N would stay in the formula, and I know my common difference is 2. So I'm going to use this formula, and I'm going to solve for the common difference. I'm going to plug in 15 for AN. I'm going to leave I'm going to solve for A1, and then I'm going to put 4 in for N and 2 in for D. So since I know all these pieces except the first term, I can see that my first term is 9. So when I'm writing my explicit formula, I do want to distribute this 2 in. So I have 2n minus 2. So 2n minus 2 plus 9 would give me 2n plus 7. And so this would be my explicit formula. And then if I put the 9 in, this would be my recursive formula. So now they're telling us the first two terms of an arithmetic sequence are -8 and -2. Now they want us to find the formula for the nth term, meaning we're going to write our explicit formula, and then they want us to find the 40th term. So I'm going to use my explicit formula, and I'm going to plug in everything I know. So I don't know my common difference, but I know A1. I do have an N and an AN because they gave me another term. And so now I can just solve, and I'm going to get that D is 6. So now if I'm going to write my explicit formula, I plug in -1 for A1, -8 for A1, and 6 for the common difference. So my explicit formula would be, should be -6, sorry, so it'll be -14. Now to find the 40th term, I would take 40 and substitute in for n. And so my 40th term would be 226. All right, the second term of an arithmetic sequence is 10. And the 11th term is 37. So if I'm thinking about how do I find the sixth term? Okay, so first I want to write my explicit formula. So I know that A2 plus 9 more common differences would give me 37, because that's how you get from 2 to 11. So 10 plus 9 common differences would get me to 37. So it means my common difference would be 3. Since this is a linear equation, we could also do slope formula, y minus y over x minus x. And this would also give us a common difference of 3. So now that I know my common difference, I am going to solve for my a1. So I'm going to use this point. So I'm going to say 10 equals a1 plus 2 minus 1 times 3. So 10 equals a1 plus 3. So a1 would equal 7. So my explicit formula would be 7 plus n minus 1 times 3, which when you simplify that would be 3n plus 4. So to find the sixth term, I would plug in 6 for n, and I would get that a6 is 22. All right, now it's saying how many terms are in this arithmetic sequence. So I know this is a1. I can see that my common difference is 6, because I would add 6 to go from term to term. And this is going to be my an, but I don't know what n equals. So if I use my explicit formula and plug in everything I do know, I can solve for n. So that means there'll be 54 terms in this sequence if the last number was 336. All right, in 5, it's telling us that we have these 3 terms, a1, a2, a3, are the first 3 terms of an arithmetic sequence. Find the value of x, and then they want us to find the 15th term. So I know that a1 is x minus 2. I know that a2 is x plus 5. And I know that a3 is 2x plus 1. So I know that to find my common difference, I could do a2 minus a1, or I could do a3 minus a2. Either way, I would get 7. Actually, in this one, I would get x minus 4. So let's use our a1 minus a2 to get us 7. So now that I know my common difference is, I can substitute into my explicit formula. And so if I know the third term, and I know the first term, and I know the common difference, I can solve for x. And so I get that x equals 11. All right, so if x equals 11, that means a1 is 9, a2 is 16, and a3 is 23. So it means I'm going up by 7s, which I knew already. So to find the 15th term, I would do a1 plus 15 minus 1 times 7. So it would be 14 times 7. It's going to be 107. All right, Violet makes gifts for Valentine's Day. She has 13 baskets left over from last year. So this is how much we're starting with. She plans to make 12 each day. That's our common difference. She wants to work for 15 days. How many baskets will she sell? So we're starting with 13. We're going to work for 15 days at 12 baskets a day. So we end up with 181 baskets. And actually, instead of AN, I should have labeled this A15 because that's how many days she was working for. All right, in 7, it says there's 3 consecutive terms, and their sum is 24, and their product is 494. So at first when I thought about this problem, I thought, okay, so you got your first term, and then your second term is plus D, and then your third term would be plus 2D. But this is going to make for a really complicated equation. So instead, what if my middle term is N, and then my first term is N minus D, and then my third term is N plus D? So I know that N minus D plus N plus N plus D is equal to 24. So that means 3N would equal 24. So that means N would equal 8. Now I know that N minus D times N plus D would equal 24. So I know that 8 minus D times 8 plus D is equal to, oh sorry, not 24, 494. That's the product. All right, so let's multiply this out. So I'm going to have 64 minus 8D times 8 plus D. So I'm going to have 512 plus 64D minus 64D plus, actually minus 8D squared equals 494. So I'm going to have 512 minus 8D squared equals 494. So now I can solve this using square roots. I do not need to factor. So I'm going to subtract over this 512, and I can also divide by negative 8. So D squared would equal 2.25. When I take the square root of both sides, my common difference would be 1.5. So my common difference is 1.5. And my N is 8, so that means the middle term is 8, the term before it is 6.5, and the term after it is 9.5.